morning. Today we're going to do polar form of complex numbers day 2. We are going to learn how to multiply and divide with polar numbers, which I know you're so excited to do. And we get to do Demoivre's, I don't know. Somebody tells you I'm saying it wrong, I probably am. So the first thing we're going to do is we're going to multiply complex numbers. So if I have two complex numbers, z1 and z2, and I'm going to multiply them, first I multiply the radii, and then I add the angles, right? So I don't know if you can see my pen here, so we're going to multiply the two radii, and then we're going to take theta 1 plus theta 2 for the cosine, and theta 1 plus theta 2 for the I sine. These formulas will be given to you on the test. I do not expect you to memorize them. So all of the formulas that you are getting today will be provided for you on the test. So if we are going to multiply z1 and z2, z1 times z2, it says I need to multiply r1 times r2. So that would be the square root of 2 times 2 square root of 2. And then, right, I'm going to use this lower one here because it's always easier to write less, especially with this pen. Cis. And then remember, with my angles, I'm going to add them. So it's 205 plus 118. Don't forget my degree symbols here. So let's see, square root of 2 times square root of 2 is 2, 2 times 2 is 4. So I end up with 4 cis 323 degrees. And that's it, I'm done. I have multiplied my two complex numbers in polar form. Do one more, this time in terms of radians. Still the same concept, we just have to deal with the fractions a little bit more. So if I'm going to multiply z1 times z2, I'm going to take 3 times 5, and then I'm going to take my angles, pi over 4 plus pi over 6. And this part isn't quite so much fun because we have to deal with common denominators. 3 times 5 is pretty easy. And so in this case, my common denominator would be 12. So I'm going to think about this as being 3 pi over 12. And this one as being 2 pi over 12. So that my final answer will be 15 cis 5 pi over 12. And that's it. I'm done. The most complicated part of the polar form is just getting the common denominator in order to add the fractions. So our quotient rule is very similar, except this time, if you notice, instead of multiplying the radii, we're going to divide them. And instead of adding the angles, we're going to subtract them. And notice z2 cannot equal 0 because, right, you can't divide by 0. You cannot have 0 on the bottom part of a fraction. So if I'm going to divide these two polar equations, to find z1 divided by z2, right, I'm going to take z1, or sorry, radius 1 square root of 2 divided by radius 2, which is 2, cis, and this time I'm going to subtract 90 minus 60. So that my final answer should be the square root of 2 over 2 cis of 30 degrees. And that's it. Do one more example, this time with radians. So if we're going to divide these two, I'm going to take my first radius, which is 6, divided by my second radius, which is 2. And I'm going to have to subtract these. Now, because I know what's coming from the multiplication, I'm going to get my common denominator right now, which once again happens to be 12. So pi over 3, I'm going to write as 4 pi over 12 minus pi over 4, I'm going to write as 3 pi over 12. So I just skipped a step and went straight to getting a common denominator before subtracting my angles. So my final answer should be 3 cis of pi over 12. And that's it. The last concept for today is De Moivre's theorem, and he just helps us find the root. Notice this time we're going to a power. So if I want to square this or cube it or take it to the 5th power, this is just a shortcut, so I'm not multiplying and foiling everything out so many times. So to find z to the 4th, what my formula down here tells me, right? I'm using my cis formula again, once again. So z to the 4th is equal to 2 to the 4th power cis of 4 times 70. So 2 to the 4th power would be 16, and 4 times 70 would be 280 degrees. And that's it. We found z to the 4th with De Moivre's theorem. Last one, only reason this one's more complicated is because we have fractions, but we're going to find the z to the 3rd power. So z to the 3rd power would be my radius to the 3rd power, cis, and then I have to take 3 times my angle, which this time is 5 pi over 3. So 3 to the 3rd power is 27. And cis, let's see, the 3's cancel and just leave me with 5 pi. And that's it for today. Today is just a matter of using your formulas appropriately and plugging them in. I do want you guys to notice on your homework, I know number 39 is a typo. I think it says 4z or something crazy, but it's just a typo, and they want you to find z to the 4th with De Moivre's theorem. Have a great day. Bye.